We're here with more back to basics 3D printing goodness. Today we will start our very first 3D print. Hello everyone, Chris here. We're doing a back to basic 3D printing series where we try to get new users up and running as quickly as possible. Trying to give you all the tips that you need to be successful in your 3D printing journey. Now we are going to do a lot of these videos, so if you're interested in this, please click subscribe and hit that bell for notifications because we do release one every week. Now with 3D printing, technology has changed over the years. A lot of the things we're going to talk about today are very basic, and the newer machines handle all of this for you. You don't even have to worry about it for the most part. But if you have this information, it's going to give you a lot of insight into troubleshooting and how to resolve issues down the road if you do have some. So definitely check it out. Now we're going to start with the first layer. There are different types of technology of 3D printer. These are filament-based 3D printers, and that's what all these videos are going to be focused on. It's the most common type. You might hear them called FDM or FFF. But that first layer that goes down on your bed is crucial to having a successful 3D print, and will come into play in a lot of different scenarios as we move on to more complicated things down the road. So that's where we're going to start today. We're going to talk about that first layer. So from here, we're going to continue to talk about our Prusa Mark III. The Mark III came out in roughly 2018, and it was the top of the line in technology at that time. Now the Mark III has a lot of features, but you still have to be concerned with getting that first layer set just right. Now the Mark III does have auto bed leveling. It has a probe here. It's an inductive probe that measures on this metal plate by probing different areas so that it can tell how far the probe is away from the sheet. Note I said that measures how far the probe is from the sheet, not how far the nozzle is from the sheet. So there is always a bit of an offset that you have to adjust. Now on newer 3D printers, we'll take a look at another one here in a moment. You don't have to worry about that any longer. It takes care of that first layer for you, but it's good to go over it. Now there's a lot of different settings on a 3D printer that are going to help you achieve that first layer, but two are very crucial. The first one being, you want to make sure that your print head, or your nozzle, is level to your bed. Now that's not level like using a spirit level to ground. It's the nozzle level to the sheet that you're printing on. Now on a printer like this Prusa machine, we really can't control how level Y is. This is a moving bed 3D printer. This frame is very square. So we are going to assume that the level back and forth on this printer is perfect. Anything that we need to compensate for, we'll be able to do that with auto bed leveling. Before auto bed leveling, we would do that with knobs on the bottom of the bed. We would go around with the nozzle and a piece of paper, using it as a feeler gauge and adjusting that knob to make sure the whole bed surface was level to that nozzle. Manual bed leveling is pretty much non-existent nowadays. You're always going to see some type of leveling system. So we assume, because of the frame of the printer, that Y is all set. You're not going to have any tilt in this direction, or you shouldn't at least. A lot of the printers have a sequence that will help you compensate for that. They have calibrations for it, but that's not going to be a common issue. Now what could be an issue is how level the X gantry right here is to the bed. We have two different Z screws, one left, one right. One of these could be skewed one way or the other, meaning this side was taller or lower than this side, causing skew in this direction. One side higher than the other. That's the first thing that we need to fix before we can get our first layer down. Now we are dependent on most 3D printers for the frame to be completely square. If it's not, you have a much larger problem, of course. But we can assume on all of these Prusa machines, a lot of the i3 machines, that it is square from here to here, front to back. But when we're talking about X, we want to be concerned with how square it is in this formation. These two corners, these two corners. And since we take into account that that is always square, all you have to do is make sure your gantry is square. And you can do that by raising it all the way up to the top of those screws. We push it into these mounts, and we know that the gantry is the same on this and this mount. On the older Mark III model, they have the LCD screen, but you would just go in, go to Calibration, and go down to Calibrate Z. And when you do that, X and Y are going to home to make sure they're in the correct position, and then it's going to raise that X gantry all the way up and top out on these Z mounts. You can hear it buzzing. It has collided with those two mounts. Now we know that the X gantry is square with the frame, meaning that it will be square with the bottom frame as well. So square and level this way with the print bed. Now every sequence on every machine is going to be a little bit different, but with this one, when we're all the way to the top, we can click the button. It asks you if your sheet is on. Your print sheet should be on because it's going to probe on that sheet. We want the accuracy to come from this sheet. And we'll just hit yes. Now what it's going to do is go down, probe several points on the bed all over, and build a map. That map is what's used during the print to tell the Z motors to adjust to compensate for any discrepancies. The default on a Prusa is 9 points when you do the calibration. That should be enough information to give you a pretty flat map to be able to print on. The sequence is now complete. It has saved that information in EEPROM or memory, and it's going to use that info now every time you start a print. Now, you will see the printer redo this map during the start of the print to make sure everything's ready to go, but that's more of a precaution. This should not change that much in between prints. It's important to understand what we just did here. You saw that auto bed leveling sequence. We raised the X gantry all the way up to the top of the frame to make sure it was square with the frame. It's square at the top, it's going to be square at the bottom. And that's going to make it parallel to the bed, the print surface. Then the probe took a bunch of different measurements on the bed surface and created a height map. That map is going to be used during the 3D print to adjust the Z motors up and down to compensate for any discrepancies in the bed level, if it's not completely flat. It's going to be pretty close, but remember, we're dealing with tolerance around 100 micron here. Very small amounts that it's going to be able to compensate for. It'll be a little easier to understand as we move into setting that first layer height. So with that Z calibrate, we now know the X gantry is parallel to our print surface. Now we need to set that first layer height. A lot of printers now have a stored print inside the memory that you can run to test that first layer height, because the best way to do that is to actually print something out. So let's move to loading filament. So here's the filament we're going to use for most of these videos. PLA is the type, it's the easiest to print, the most common, and the best for the new user. This is where all new users should start out. But this is Prusa Galaxy Black. It's a very high quality filament, meaning the tolerances are very tight. And that's very important to getting good quality 3D prints. The first thing we want to do to start loading filament is go to preheat. Again, every printer is going to be a bit different, but we're going to preheat for PLA, because that's what we're using today. That gives you 215 on the nozzle and 60 on the bed. These are heated beds. Almost all printers have those nowadays, and those measurements are in Celsius. While the printer preheats, it's important we talk about the print surface. There are different kinds of surfaces for different kinds of filaments. This is what they call a smooth PEI sheet. PEI is a type of material that sticks really well to a lot of different types of filament. PLA, this is my favorite type of sheet to use. It grips it pretty tight while the print's moving, but then when it cools down, it releases it relatively easily. You want a good mix because you don't want to fuse your filament to the bed. You want to be able to remove it later. But you definitely don't want it to pop off during the print. So it's important to select the correct type of sheet for the filament you're using and to clean it properly. To make sure your PEI sheet is clean before every print, make sure your printer is cooled down. You never want to clean one of these hot. I've removed it today to save myself a little bit of time during the preheat, but it is a completely cool sheet, and I'm going to use 90% IPA, isopropyl alcohol. You can get this pretty much anywhere, but it's got a lot of water in it, so it cleans well and dries quickly. The biggest thing you want to do is get all the fingerprints off the sheet. You don't want any oil on it so that it sticks well to that filament. So we'll just spray it down and we'll wipe it with a clean paper towel. Now, if you don't wipe in one direction, it's really easy just to push the oil around if there is any on it. But we're just going to go in one direction and pull it to one of the sides or the front or the back, whichever's convenient for you. I like to go over it twice myself. But now the sheet is nice and clean, we can put it back on and we'll have the best chance that we can get to getting that first layer perfect. If alcohol, using a paper towel, that's not doing it for you, if it's not getting it clean enough, I recommend just taking it to the sink and using dishwashing liquid, something like Dawn, to scrub it down and then let it dry. That's the best way to make sure they are 100% clean. Dishwashing soap does a great job. But we'll put this back on our machine for now. The sheet is back on, our hot end is up to temp, 215 to 215, and our bed is almost there as well, 56 out of 60. But when the hot end's up to temp, now you can load your filament. How you handle filament is also very important. You want to make sure that you always have the end of the filament in your hand. If you let it go, you could lose track of the end of it and it could fold over onto itself, creating a knot. And you won't find that knot until you're in a critical part of your 3D print that's almost guaranteed. Then you have to dig it out, take layers off to try to get out of that knotted situation. So always keep one hand on the end of the filament. When you're done with it, make sure there's a keeper on your spool of some kind, a set of holes. On the Prusa spools, it's just a honeycomb, so it's easy, but put it back to make sure it's retained while you're storing it. But for now, we're going to load it up. One thing that you can do to ensure that you get your filament loaded correctly every time is to take a set of flush cutters like these and put a nice point on the end of the filament. Try to get in there and make that point on the filament as sharp as you can, because the extruder gears are going to like to load that a lot better than a blunt tip. So we'll just cut it, and now we have a nice sharp tip that will load into those extruder gears. We'll just mount our spool up here on top onto our spool holder, and on our Mark III you can see the extruder gears right here. These gears are going to grab the filament and take it down into the hot end. You can see that hot end right there, and take it all the way down to the nozzle. This hole here on top is where you load your filament, so we'll just put our now sharp tip in that hole. And the Prusa Mark III has a filament sensor that can tell if filament is present or not. It could tell that the filament was present, so now it's taking it all the way through. You can see the white filament unloading and the black filament loading. So it went through the auto loading sequence. When it's done, it's going to ask you some questions. Was the load successful? If it wasn't, you can eject it and try it again. Was the color correct? Did we load enough filament? If you're going from one bright color to maybe a white filament, you might want to tell it no, so it kicks out just a little bit more filament. Remember, again, every printer is going to be a bit different, but we saw we went from that white to the black filament successfully, so I'm happy with that filament load. So I'm just going to say yes, the filament is loaded successfully. Now once you have the correct sheet on and your filament is loaded, you're up to temp. The Prusa printers have a test print we can load to set our first layer height. So we can just click the button, go back down to Calibrate like we did before, and we're going to go to First Layer Calibration. Now you can see Z has an offset here. That's because I've run this calibration already. But for this video, I'm going to hit Reset. That's going to take that back to 0. That's the offset from the nozzle to the probe. It's going to ask you again, if you didn't preheat before, what filament you'd like to do that level test with. We loaded PLA. And then it's going to start a print. Now since we're calibrating that first layer, it's going to run a bed level again to make sure that height map is correct. And then it's going to start printing a test pattern. This first line you see down here in the front, that's a really wide extrusion to make sure that your nozzle is primed. But then it's going to create a zigzag pattern all the way to the front of the bed. Now remember, we reset that offset during the start of this calibration to 0. So the nozzle is really far away from the bed right now. You can see this filament. I can just flick it off. I can move it around. It's not stuck to the bed at all. Now we're calibrating for the smooth sheet right now because we want to calibrate for the sheet that we have with the PLA. This knob will start cranking down the nozzle so that it gets closer to the bed. Because of how the configuration on this printer is, it's always going to be higher at the beginning. And then we'll start backing down into the negative to get it closer to the bed. While you're turning this down, it's important to watch that first layer to make sure it's getting down to an acceptable level and you're not digging into the bed surface. During that first test sequence, we dropped the nozzle down about 600 micron, a little more than that, but we dropped it down as the print was printing. So it's actually getting closer to the bed the further to the front that we come. So in the back, it wasn't stuck at all. And then we started to stick just a little bit here in the front. And it prints a little square here in the front so that you can tell how the layers are laying down next to each other to see how high off the bed they are. And they're really not stuck at all. So we're getting there, but we need to come down to the bed even more. So on the Prusa printers, it's real easy. We can just run another one of those sequences. And this is the setting that we changed when we ran it the first time, because remember we were set back to 0. We're at 0.665 right now, but we need to come down even more. So instead of resetting it, we'll just hit continue, so we can continue from that setting on. PLA again, so it preheats for our filament, and then it'll start printing out that zigzag another time. Now this time, as we start our test print, it's important to monitor the print that's being laid down. It has to be stuck, it can't move around, but you don't want it stuck too much. If you get too low, that's going to collide with the bed and ruin your surface. So it's still moving around, we're safe to go ahead and come down some more. Remember, going into the negative even more is bringing it down, the nozzle closer to the bed. Check it periodically. I just like to check it with my fingernail to make sure that it's stuck. We're at 1.128 right now. It's stuck, but just barely. So I'm going to take it down to 1.220. That's about where I had it before. You saw that measurement when we started, the one I reset. And don't worry, if you make the change here in this calibration, it's going to save it for the next print. You don't have to do this again. Just when you're switching sheets or switching different types of filament. And with that last adjustment, remember it's coming down as it's printing. So over in here, we got to our final adjustment. It's not easy to get it off the bed with your fingernail. It's stuck pretty well, but you don't want it too stuck. And then our test square here, we can peel it off. But when you do, you can see that all those layers are stuck together, one after another. So you have a pretty good first layer setting here. So this should be good for PLA. And if you're still confused about what good first layers look like, Prusa has great documentation trying to give you an idea of what it looks like on the printer. You can see too high or too low here. And then if you're looking at it from the side or testing it with your fingernail like we were just doing, imagine this is what the filament looks like. This is just setting on top of the bed. This isn't quite enough squish. But about half of the width of the filament is where you want it to be for that first layer. Then you'll stack on top of that, of course. I'll leave a link again to all this in the description. So now we have a decent first layer with our PLA filament on our smooth sheet. We're ready to go ahead and give a test print a try. Now we were focused on creating your own 3D prints in Fusion and then slicing them. But there's a lot of great places out there on the internet to download STL files that are going to work great for a lot of your different projects. So now let's head to Printable's, my favorite STL site, and download something and get it set up to print on the printer. Printables is the STL site from Prusa. They have a lot of great features on here, but it's a pretty good database to get different files if you need to print one. You can search and explore the site as you wish, but let's just find something simple for our demonstration today. And for our first download and print, let's start with something simple. How about this measuring tool from Jamehz? Remember, these are all user uploads, but we'll click on that one. It's a very simple print, but we just need the STL file. So we'll hit download. That will take us to the files section. There's probably multiple STLs. They should have a description, but we're just going to download this basic one right here, creditcardruler.stl, and we'll hit download. This is going to download the STL file that we can take into our slicer. We go over STLs and slicer in the previous video. Back into Prusa Slicer, we have our settings. These are the defaults that we used in the last video, but we're doing a 0.2 speed print setting. That's good for most prints. We have it set to our Prusa PLA that we just loaded, and this is our printer setting, our Mark III Prusa 3D printer. And then from here, we can just bring in that STL file. So we'll click this icon to add. We'll find that credit card ruler STL that we just downloaded, and we'll hit open. And that's brought our STL into our slicing program. You can go ahead and hit slice to get it ready or turn it into G-code to take to your 3D printer, but this will also allow you to inspect it to make sure it's going to print correctly. It's always a good idea to go through all the layers of the print to make sure it's flat on the bed. Because remember, we're after that first layer, the perfect one. And this is laid flush on the bed. All the layers look good, so we should be okay. Now, different things that you might see while the 3D print is going down. We already talked about the prime line here in the front of the bed. That's to make sure the nozzle is primed before it moves to the print. So the extrusion on that is a lot wider than it would be on the rest of the print. And then if you zoom in, you see this line around the print. That is called a skirt. The skirt is doing kind of the same thing that the prime line does, only closer to the body of the print. It prints this line around the model to make sure the flow of the nozzle is consistent before it starts printing the actual part. This ensures that you have the best quality on the part that you can get. The Prusa default on a lot of their machines is to do this for the first 3 layers. That will usually move you into infill, where the print is moving quicker. You can tolerate any discrepancies a lot easier, but this one does do it for the first 3 layers. So you're going to see that skirt. It is a waste object, but it is just one width of print. But this looks good, so we'll get our SD card from our printer. Remember, I showed you on the Mark III, it just has the SD card on the LCD screen from the last video. We'll just remove it. And then when we mount it on the PC where we're slicing, when it gets mounted, you see this icon down here. That will export this STL, the one we just sliced, to your SD card. So we'll hit that button. It brings up the SD card that's defaulted on your printer. Hopefully you only have one, but mine is named after this printer. You can see it up here. And then we can just hit save if we're happy with that name of the STL. It does add things to that STL name to try to tell you how you slice the print, like layer height at 0.2, PLA filament type, the printer you sliced it for, and how long the print's going to take, just to help you track those files a little better. But we'll save it on our SD card. Now we can eject that SD card with this button right here, remove it from the PC, and take it back to our printer. We'll remount our SD card. When you do this on Prusa printers, it defaults to showing you the list of files. The newest one should be first. You can change that order if you like, but there's our credit card ruler right there. But now that we have our first layer calibrated, all we need to do is clean the bed one more time. It is important to clean the bed before every print to make sure you have consistency. Remember, the bed needs to be cool. We'll spray it down with our alcohol, wipe it off in one direction. It will dry really quickly, and then when it's dry, we're ready to start our print. If you need to go manually find that G-code file that we just uploaded, just click the wheel, go down to Print from SD. That'll bring up the list of what's on that card. Newest one first. We'll click it, and it'll start printing. You do have to wait for the sequence for the bed to heat and the hot end, but once they're up to temp, the print will take off. Once the printer is up to temp, it does a couple of things to make sure it's ready to print. One is auto home. That makes sure it goes all the way to the left side of the printer, pushes the print bed back, and it touches the probe to the bed, so it makes sure it knows 000 or home, so it knows where to start the 3D print. So it is homed X, it's going back to home Y, it's homed, and then it touches the bed to home Z. Now it moves into that auto bed leveling sequence. It does this before every print, just to ensure the bed is flat, there's no discrepancies. Then it moves to the prime line in the front of the bed. This also gets any debris that might be on the nozzle off. And then it starts printing that skirt around the print. Once the skirt is complete, it will start printing our ruler. Even though we've calibrated the first layer, you can always adjust that first layer on the fly. Right now, I would say that we could use just a little bit more squish on the bed. It's a little tall. While the print's running, you can click on the knob on Prusa machines and go to Live Z Adjust. This is the same setting that we set in the first layer calibration. If you go further into the negative, that's going to give your print a little bit more squish. But remember, don't do too much or it will dig into the bed. Let's just take it up to 245. That does this live on the fly. It adjusts the Z motors. It was a very small adjustment, but if you were able to look really closely, you can see that the skirt here is before we made that Live Z adjustment, and the bottom layer here is after. Including these parts inside here, these perimeters, those went down before we made the adjustment. You can see that this bottom layer is just a little bit closer to the bed than the other print lines. So we increased the squish on that first layer. That'll ensure it sticks as well as possible so it doesn't come off mid-print. While your print is printing, it's going to try to give you an idea of how much time is left and a percentage. This is the SD card measurement, how much of the G-code has it processed. And this is an estimate of the time remaining, 19 minutes. Up here gives you the Z height. We're currently on the first layer. You saw the print setting was set to a 0.2 layer height. We're on the first layer at 0.2. This will increase by that layer height as the print gets taller. Our print is complete. The next very important thing you need to remember is to not remove a print when the print bed is warm. We want to make sure this gets down to room temperature before we try to remove it, because that could damage your print surface. While our bed cools down, it's important to mention that every 3D printer is going to be just a little bit different. But that first layer is always going to be important. It's just how you achieve the perfect layer based on the manufacturer. So consult with them. They should have a set of steps that enables you to get that first layer completely perfect so that the rest of the print goes well. Now, for instance, on a Prusa machine, they do have a built-in test print. Well, what if you don't have one of those? Just like we saw with our test measuring device, we'll go back to printables, and let's just type in bed level test. You're going to have all kinds of different options for different leveling tests you can do, even ones that are very similar to that default Prusa test. Some are going to be even better. Take this one here, for example, by Jacob. You can just download that, and since you already know how to get your printer set up to print an STL file, grab your STL file, download it, load it into the slicer, and then you can print this and achieve the same results. It's all about watching that first layer go down. And remember, I said before, a lot of the newer machines have a sensor or some way of telling how that first layer is going down, so you don't even need to do a lot of these steps. And that's where the Prusa Mark IV comes in. it has a lot more built-in smarts, so you don't even have to worry about that first layer any longer. And this is the Prusa Mark IV's, but it uses the nozzle to check the bed to make sure our first layer is going to be correct and to build our bed mesh. It has a load cell that when the nozzle touches the bed, it knows where it's at, and then it knows how to set that first layer. So it works as the probe. But having that advantage gives it the ability to tell how high that first layer is going to be. And the newer printers have a different interface. Whether you have a 3.5, 3.9, or the Mark IV, you can do the same types of things. If you go into Control and then go down to Calibration and Tests, you're still going to have the same types of tests. For instance, the load cell test, that's where it's going to allow you to test the load cell to make sure it's calibrated correctly. And the Z-axis test, which is exactly what we did on the Mark III. So if you run that, just like on the Mark III, we saw it run the gantry all the way up to the top to make sure it's parallel to the bed. Then the Mark IV is going to check the X and Y axes repeatedly to make sure the home is correct. And then it will touch the nozzle to the bed to probe it, and then take it all the way back up to make sure once again it is parallel after the test. So it's achieved the same results, just in a little smarter fashion. And again, because the nozzle is the probe on the newer machine, you don't have to worry about that first layer when you're moving to different types of sheet or different types of filament. Now back to our test part. We're getting cooled off, we're down to 35°C. That's probably cool enough to go ahead and remove your print. And the reason that you want a heated bed in the first place is to keep that first layer of filament as it goes down just a little bit soft. That helps it adhere to the bed and stay that way until the print is complete. So if you were to take this off when the bed wasn't completely cool, it could deform because it probably is close to the transition temperature that it turns back into liquid. Now, most printers nowadays have a removable sheet, just like the Mark III does. The best way to remove your print is to remove the sheet and then flex it to pop it off. If you don't have that option, some sort of scraper is going to be your best bet. I just use something like a paint scraper. You can get under the corner and lift it, but be extra careful that you don't gouge a hole in your print surface. But since we do have the removable sheet, these are available on pretty much every 3D printer. You can just remove it and give the sheet a flex. That'll lift at least one corner of the print, and then you can peel it right off. Now we have our completed print. We can further inspect that first layer. It looks good. No sparse layers where we might need to add a little bit more squish. And then on the top finish, you shouldn't see anywhere where the nozzle has dug in. That would indicate the nozzle is too close to the bed and you'd want to back it off. But this looks like a really good quality print. So I think that's more than enough information for one 3D printing video. But we did go over how critical that first layer is on every 3D printer. We got into some filaments versus bed sheets, what you need to look for, as well as we're trying to bridge that gap from STL files you might find on the internet, how you bring them into the slicer, how you orientate them to make sure that first layer is going to be perfect, how you support it, we went into that in previous videos, and how some of these printers now have automated processes. They're just a little bit smarter to keep you from having to worry about a lot of this. So if you're going to make a 3D printer choice, you're going to buy one before you get started, keep all of that in mind. But again, this is great info if you ever have to troubleshoot an issue. So that's it for today. Hopefully you found this helpful, and I'll see you really soon on the next one.